Hello, and welcome to the Light Reading Podcast. My name is Phil Harvey. I'm an editor here at Light Reading.
I'm Kelsey Zeiser, and I'm also an editor at Light Reading.
Welcome, Kelsey. Thanks for being on the podcast.
Thanks for having me, Phil. I've always wanted to say that.
I know. Hey, were you ever old enough to, or did you ever run into, I should say, because I'm barely old enough to know this, but like Corning, the makers of fine fiber optic products now, used to actually make glassware for cooking.
Oh
'Cause they
yeah,
were,
I think yep. I think we've since my family hoards everything,
yeah, it
we've
just popped
surely
into
got
my
some of
head
that.
when I was thinking about Corning and its history as a company, and I was just thinking, oh yeah, they used to make like casserole dishes and stuff. That was
Yes,
kind of cool.
I'm sure we have some.
But now they are
We
all
still
about,
have the Fiesta ware, so there you
yeah.
go.
Oh yeah, this store is cool.
Yeah, it is cool.
It's a hot item to thrift.
Yes.
But we're talking about Corning, and we're talking about fiber now, especially the demands that AI and generative AI are putting on the connections inside the data center, and then also outside the data center. Between data centers, and of course in the medium and long haul networks. And joining us on the podcast were Bob Whitman, Global VP of Carrier Networks for Corning Optical Communications, and also Brian Rhoney, who's a Director of Enterprise Market Development for Corning. And, since they're such different worlds, but they're both using Corning fiber and kind of cutting edge technology, they both kind of came at the problem in different ways. And it was a pretty interesting conversation.
Yeah, I thought it was nice to be able to talk about how things are changing in terms of needs for fiber capacity inside the data center, and then also data center interconnect and long haul networks. And we also talked a little bit about their recent deal with Lumen, which is pretty big, and what that might mean for other service provider customers.
Yeah, and that's where it kind of hits our core audience is like this opens up opportunities for telcos in the same way that Lumen is kind of taking advantage of the what it already has in its network and adding to that capacity. But it's very clear that as enterprise needs um, evolve and generative AI becomes, a more and more useful technology, that, Corning's got a lot of work ahead of it. And telcos have a big challenge ahead of them in not just addressing the complexity of the connections needed, but also a big opportunity in terms of, satisfying those connectivity needs both inside and outside the data center. And you'll hear all about it right now. Okay, Bob Whitman and Brian Rhoney from Corning, thank you both very much for being on the podcast.
Thank you.
Thanks for having us.
Good to see you too. And so, of course, we're talking about how the data center is changing, what demands AI is putting on the connections both between and within the data centers, and the broader market, and then, of course, how telcos are responding to all of this. But let's start inside the data center. Brian, probably your area of expertise. Let's what does generative AI and the demand that's going to put on the data center, how is that different than what we've experienced so far with let's say cloud computing and kind of general enterprise connectivity?
Great question. With traditional cloud, most of the interactions are between the end user who wants to access that cloud or that application and that device. So it's very north to south connections from the user into the cloud. With generative AI, a lot of what we're doing today, a large portion of the AI is in training those algorithms, those generative AI algorithms. In that, we need a lot of machine to machine connection. So traditionally, we would call that east to west connectivity within the data center. So, with AI, as we're generating these models and training these models through a large data set, we do that through parallel processing. So we're breaking up that data set into smaller pieces and engaging multiple devices in that training process, which is what we call parallel computing. When we do that, we have to connect all of those machines together in a mesh. You might hear the term neural network, similar to the brain, making all of those connection to connection devices to allow that parallel processing. And that is unique. So we still have that traditional, what we would call front end network or traditional cloud network to those devices to feed the data into the system. But now we have an additional network called the backend network that's really allowing that machine to machine communication during the training process. And that has increased the amount of connectivity from the device to device by about 10x per rack to achieve that connections.
Wow, that's a well, that's great description of it, and also very compelling because we're not only is it a new kind of connection, but the connectivity and the computing is going in different directions than what the network is usually equipped to handle. So I guess the next logical question means, what does that mean then for like how and where and what type of fiber is used in the data center?
Yeah, great question. As far as, let me address that first with what type. So traditional fiber, which is multi-mode and single mode, are both being leveraged in current systems that we're deploying today. However, the kind of tweak on that is size, overall diameter of the fiber. Because of that 10x growth in the amount of connectivity, we need to shrink that package in which we deliver fiber and connectivity between these devices. And so, at Corning, we've innovated to uh, reduce fiber footprint as well as cable footprint, uh, and even including connectivity footprint to connect those devices because of that density challenge. And I would say, really the connectivity extends now with fiber all the way into the server racks themselves. These traditionally have been fiber to a server rack and then copper within the server rack. With AI, we're actually taking fiber all the way to the GPU NIC itself.
Yeah, that's an quite an quite an interesting change, and also a compelling challenge for a company like Corning because, like, just to pick up on something you said there, that that means the space requirements, especially in existing data centers, it's like well, they haven't gotten any bigger,
Yeah.
so it's like so now we have to do all of this in a more compressed area and still be aware of heat dissipation and
Yes.
temperature and things like that. And then the other point, this was definitely something we talked about at OFC, was yeah, just how far fiber is going into the server or directly to the server, where there
Mhm.
used to be this nice little handoff into the server rack, and then there was kind of the server rack had its own sort of connectivity
Mhm.
system, and now it's all using fiber. So I think those are important to keep in mind. And I guess the last question I have on sort of this aspect of it all is 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 this just going to be the way things are now that we're in this build out phase? Is this a constant that we're looking forward to, or is this just kind of a one time build out and then we get it set and then um, robots take over the earth or whatever the evolution of AI is?
Yeah.
But
Don't
how
jinx us, Bill. Jeez.
how steady, I guess a growth path is this on? Because that I guess that's a maybe this is more my telco mindset, but that used to be kind of what we would experience in the connectivity, um, push that telcos would make. They have a build out phase, then everything would settle down, and then they'd stop for a while, and then the next generation of either wireless or wired connectivity would come along, and then there'd be another build out phase. And what does that look like inside the data center?
It's a question we often talk about because we have walked down your very pessimistic path that you just mentioned in the past, right? With telco build outs and then some market corrections or market events that were not so favorable. So we ask ourselves that question, and you know, and to our end users to try to understand where their thoughts are. And I would say, simply said, will GPU build-outs and clusters continue to be required to grow and get bigger and larger? And I think the answer clearly is yes. For the next decade, we see nothing but the number of uh, parameters, if you will, or inputs that we're trying to train keeps increasing at a pace that's very difficult even for the GPUs to keep up with, which means if there's a gap in GPU capacity versus the complexity of the algorithm that we're training, how do we correct for that? We correct for that by building bigger clusters, put more GPUs working on the problem at the same time. So today, we talk about state of the art being 30,000 GPU clusters, training some of the modern kind of large language models that we talk about today. But as we move into some imagery of large language model training, we need hundreds of thousands of GPUs in that cluster to achieve that training. So kind of the pace that we expect is new GPUs every year and a half to 2 years, building those into bigger clusters. Those old clusters eventually get used for inferencing instead of training. So we have this need to get up to the kind of the golden rule that everybody talks about, which is a cluster of about 1 million GPUs, which is 1 million GPU equivalents to the H100 to kind of do general AI. And that's the kind of the golden standard, which we're years away from getting there, but that is the gold standard that we're marching towards. So I said a lot to say we definitely don't think it's a bubble.
Sure.
We see, sure, there's some things out there that could cause slight pauses, maybe regulatory things, geopolitical things that could create some pauses in this space, but nothing's going to stop, in our view, that growth of cluster sizes and continued build outs of bigger clusters in the data center space.
Yeah, and to be entirely fair to Corning too, I mean, it's like you're on the infrastructure side. There's still no telling how fast the market or human beings in general will be able to absorb and process and put this technology into their, into use. And
That's
so
right.
there might be um, uh, more demand at times and then a lot less demand at times and that sort of thing. But it did kind of, and I'll put this in my minder to, kind of remind me to ask the same question 10 years from now, because it does seem like there's, there's at least a long period of steady build out while the
Mm-hmm.
capacity is getting there. And then we'll kind of wait and see once we cross that horizon, I guess, cross a horizon. But I don't know. It's time
Can we
Cross
to
use
that
it?
boundary.
help me out,
Yeah, there you
Kelsey.
go.
You're better with the words.
I was just imagining 10 years from now, Robot Phil would be
Oh, yeah,
on
yeah,
the
there's
podcast
no way I'm
asking
gonna
us
be here in 10
questions.
years. Yeah,
No,
it's gonna be a half Android cat
yeah.
probably. My cat will probably take over,
But
so
he'll have great hair. That
yeah,
robot will have great hair.
that's fine. Yeah, well, she already does, Rosie. Say hi. Anyway, so okay, let's talk about, um, outside the data center. Kelsey, I'll kind of I'll yield to you for now.
Yeah, I think, Bob, this might be kind of in your wheelhouse, but what are you expecting in terms of how Gen AI is, changing requirements between the data centers and for long haul networks?
Yeah, sure. Thank you. You've seen some announcements from us with partner before. It's clear that Gen AI is driving a tremendous amount of bandwidth, which then needs to create opportunities to connect with fiber. And Brian just spent some time talking about the cluster sizes and how they're getting bigger. And Phil talked about, well, some of these spaces are not, you got to do the more stuff in the same space, and that infers power limitations, which is one of the big drivers. And so as these GPUs get, more GPUs, more cluster or bigger cluster sizes, uh, they're going to need to be connected in different locations. And that's going to drive traffic from one data center to another. And in this case, I need more fiber in that route. And some of the places where there are data centers are not, fully built out with fiber yet. So now you have new fiber deployments in some of these satellite locations. And so it's driving fiber demand. There's no doubt about it. And it's really being those two factors of, is there fiber already? Do I need more? If there's not fiber, I need to build it. And I'm building to places that have good power grids, because that's where these data centers are getting built.
Hmm. Yeah, that's super important, and I feel like the energy conversation just keeps getting bigger and bigger, especially with prices going up. So that's no small task. Last month, Corning announced a partnership with Lumen, and was hoping you could give us a little bit of background on what that entails, and then we can dive into what that means for AI-enabled data centers as well.
Sure. So let me tell you one thing about Corning. We know you well, right? You probably know us well enough, but everything we do starts with a challenge from a customer. And we're at our best when we're working on a hard problem with a customer that wants to partner with us. And you hear that from us often, and that is exactly the case here. Our customers come to rely on us to help solve some problems. And in this case, it's really about the foresight that Lumen or Level 3 at the time had of putting in extra ducts when they were building out their networks. And now they need to fill those ducts, but they need twice as much fiber as they planned for. And we are creating a whole new system, if you will, starting with a new fiber. Brian mentioned that earlier. This is 40% of the size of the legacy fiber, and a new cable design that enables putting twice as much fiber in the same place. And so the deal with Lumen was reserving actually 10% of Corning's global fiber capacity, which is not insignificant, for the next couple of years. And this is really to enable them to make the connections for their customers that they've made agreements with. So we're very happy with what they're doing. They've indicated more projects coming. We love it. And we're very happy to help them solve the challenge of space with our new optical solutions.
Mm-hmm. And was this kind of a different type of deal or challenge for Corning? I mean, you mentioned that you shape things based on the challenge presented by the customer. So wanted to know, how unique is this, and also does this signal, other telcos, how they might be addressing their AI needs as well?
So how unique the cable design we're talking about for this outside plant is unique. It's new to the world type of cable. What's not unique is the need for density. More fibers in tighter spaces. In the case I'm talking about, we're going from hundreds of fibers in a cable to more than 1,000. In Brian's case, you're getting multiple thousands of fibers in these cables. And so this is a challenge that we've been working on for a long time. The specific outside plant cable that we're bringing to market is new to the world, and it is something that certainly Lumen is going to use, and we absolutely believe other carriers that participate in this space are going to be looking for cables that are higher density to fit in smaller places.
Yeah, that kind of answers what my next question was, how the current fiber and data center interconnect infrastructure can support AI services. So it sounds like there's a lot of runway still to go there. And then you've always got the issue of the Shannon limit, I imagine, comes into play as well.
Yeah, absolutely. I think we've seen how you could add more and more data to fibers. Even there was an announcement, I think, yesterday of another more terabit networks that are getting deployed. But we are reaching that Shannon limit, and that's why more and more fibers are going to need to be deployed. And it was, really good foresight for those spare ducts to get put in, and looks like now they're going to get filled up.
Yeah, I like that now I have an image of ducks in, fiber. Like
Ducks,
how many ducks can we fit in here?
conduit as
Yeah.
opposed to little cute
Pipes.
feathered animals.
There's all these feathers in our
I
fiber.
think that the thing with Lumen too, I mean, because what got me about when that deal was announced, I was like, wait a minute, 10% of their global capacity. I was like, for one company,
Yeah, that's
one
wild.
company taking 10% of the fire, and then I remember, like dug into it and remembered that it's like because you had mentioned level 3 and how they built out their infrastructure, to allow for that kind of expansion and headroom, but it also, made me go down the rabbit hole of remembering that like Lumen is also Quest, Broadwing, Wiltel, CenturyLink, Global Crossing, 360 Networks. It is a massive, massive fiber footprint. A carrier with an astounding fiber footprint in the U.S. and in North America, and and a lot of those carriers that sort of eventually became part of Lumen were, I'll say like kind of regional, you know, one or two in their market, for fiber capacity and just overall bandwidth routes. They were selling to other carriers and Fortune 500s and stuff like that. So it's always been a fiber centric sort of company, but when you're putting that entire network together, that's that's a lot of demand, and it's also a lot of ducks to fill. Quite
Plastic pipes.
There you go.
plastic pipes to fill. There we go. Is there more you can give us about the newer kind of fiber technology that sort of will debut with Lumen, but what does that kind of innovation mean for for telco carriers when they're considering their outside plant needs?
Yeah. So just at a super high level, essentially we're creating. We call it a flow ribbon. It's a way to sort of interconnect the fibers together so that they're more flexible and they can move and fit into all the space that's available inside the cable. Otherwise, the ribbon cables that we had before, they were stacked, and there was some space in the corners where you had a big square block and a round cable um, that you could now fill with fiber. And the other main thing about this cable, again, because the fiber is also a lot smaller, is fiber is really strong, right? For the size of fiber, it's stronger than steel, and it can handle the tension and or compression that might occur in a cable. Typically, when we make cables, we have excess fiber length in there so that there's never any stress on the fiber. That if there's any tension, it can move. And what we're doing is saying, hey, look, fiber's pretty darn strong. It can handle this. And so we are allowing the fiber to handle some of that tension or compression that might otherwise exist.
Yeah, it's interesting because it's not just the um, the science of getting the data through the fiber, but it's like what's the fiber going to be able to withstand in these environments, and and of course, how long can it go, but also how how tightly can it go around corners? How how much weight can you put on it? How many of these can you bundle in one spot? I guess that's also Brian, maybe that's more something you deal with a lot is as you're inside the data center, that's probably that the amount of I guess bends in a fiber comes up, I guess fairly regularly. Is that something that uh, Corning is kind of obsessed with at the moment?
That's a great question because we are obsessed with it. Not only in the cable making process, like Bob said, it's 40% smaller cross-sectional area, so we can make smaller cables. But the other attribute is it is very bend resistant fiber. So we can, even in the cable making process, typically the way you create a sweet environment for that glass is leave some free space, right? So as temperatures change, as bending occurs, the fiber has space to move and get in a relaxed position. in these new cables, we don't want that free space. So we need to make a fiber that can handle, being bent more aggressively and taking some of that free space out and using that to build smaller cables. But as well as in the data center, we go from thousands of fibers of cables down to connectors that are 2 to 8 fibers each. So now they're, measured in single millimeter diameters, which you can bend much smaller. So we are obsessed with making sure that as we go to highly single mode, highly parallel systems, that as customers are routing these into smaller spaces, because now there's liquid cooling in the racks and plumbing and pipes all in the racks, that we can kind of shove this very important plumbing of light
Yeah,
into a smaller space in the data center. And I thought it would be fun just to throw this out.
sure.
It's nothing compared to Bob's deal on the outside plant, but just one data center. One data center that we're building right now, the amount of fiber inside the data center, that fiber would go around the world 8 times. So
Wow.
it's a large amount of fiber to connect these GPUs together in over 3 million high density connectors, just to connect all those GPUs in that network. So we're obsessed with not only bending the fiber, but the low loss connectivity of those fibers connecting into the optics themselves.
Yeah, I had a guy at or an executive at OFC had explained to me, or he sort of put it this way. He was like because I was asking him sort of how is computing overall changing in this in this environment, and then what does that sort of mean for telcos? And the way he explained it was that like the fiber and optics used to be the thing that carried data, from computing, between computers and between data centers and whatever. And he says, and now it's all becoming part of the computer. And he said that it's all just, that a server rack is really just another part of a computer. He goes, because it's all going to be talking together as the connections between these things speed up and the processors speed up. It will look and feel like uh, one big thing. And I guess that's how it has to kind of, in some ways, that's how it has to operate to get generative AI to work at peak capacity anyway.
Yeah.
Um,
I mean,
so
we're taking, you know, today 400 gig to a single GPU NIC. Every GPU in that cluster needs that amount of bandwidth. Next year, we're talking 800 gig per
yeah,
NIC. And so we'll start talking in the next couple of years 1.6 T to
and
a
that
single GPU, and there may be 100 GPUs in a rack. So it's a massive amount of bandwidth required to get these GPUs to be able to communicate the amount of I/O to do that parallel processing.
yeah, and then on the outside, whatever the latency requirements are for whatever application, and that's something I'm noticing that smartphone
Mm-hmm.
makers are kind of contending with at the moment. Apple's announcements around Apple Intelligence were very interesting because they were trying to temper expectations about, okay, this is going to be on the device, and then eventually, we'll be able to kind of real. And I thought that was smart because it's like, yeah, this is already outrunning our ability to keep these devices and these brains plugged in together at in real time. So I imagine outside the data center, there's going to be probably a huge step up in not just capacity but latency as well. Um, Okay, well, I think this is a good place to leave it. Kelsey, you want to ask the hero question? Let's give these guys a chance to weigh in on the future and see where we're going.
What's the over or under on Phil becoming a robot?
That's the second question. That's for after the.
Oh, okay. Sorry. Yeah, anything else that you all are particularly excited about, back with the Lumen deal, or how that shapes other work with service providers, or anything else on the AI front that you're looking forward to?
Yeah, like what'll happen next? I mean,
Yeah.
what are you sort of anticipating is going to happen either inside the data center or outside the data center? What are we looking forward to in the next like few months? I guess.
I'll just jump in and make one point. I mean, it's always interesting to try to pontificate about what could happen next, or imagine what could happen next. And I feel like we've kind of done our due diligence here. Brian was talking about how much we love to get into, bands and connectors, and how the amount of fibers that need to be connected in these data centers is immense. And so we continue to innovate to solve these challenges of space. Density is really important. So between going from fiber to cable to the connectivity and the hardware, right? We're innovating the entire end to end of that network to make it simpler, easier, lower cost, higher capacity for our customers. And so we're really excited about the opportunity to actually leverage our core capabilities to solve these problems. Not many other companies can do what we can do.
I think that's a pretty good place to leave it. Bob Whitman, Brian Rhoney, thanks so much for joining us on the Light Reading Podcast.
Thank you.
Thank you.